Hello there, this is Channel Mahendra Popat. We are discussing Geotechnical Engineering Particle Size Analysis. Soil particle size distribution is one of the most important soil physical attributes. It is of great importance to soil water movement, soil erosion, and soil solute migration. Let us go learn this. From previous lectures, we do remember that if a particle is of size 80 mm to 4.75 mm, it is known as gravel. If the particle size is in between 0.075 to 4.75 mm, it is sand. If the particle size is in between 0.05 mm to 0.002 mm, it is silt. And if the particle size is lesser than 0.002 mm, it is known as clay. It was given according to Indian standard. Widely, I can divide soil particle size in two types as coarse grained soil and fine grained soil. They are also known as CGS and FGS. I'll tell you CGS attributes first and then we will go to FGS. In CGS, more than 50% of the total material by weight is larger than 75 micron IS sieve. Particle size is generally expressed in terms of a single diameter. This is taken as the size of the smallest square hole in a sieve through which the particle will pass. So whenever I tell you particle size, you should keep this in your mind. Where in FGS, more than 50% of the total material by weight is smaller than 75 micron. CGS are cohesion-less soils, where FGS are cohesive soils. Example of CGS can be given by sand, gravel, etc., where example of FGS can be given by silt, clay, etc. CGS does not possess plasticity property and hence they are called non-plastic soils, where FGS possess plasticity property and hence they are called plastic soils. CGS contains very small amount of adsorbed water because electrochemical forces between the soil particles are very weak, where FGS contains more amount of adsorbed water because of strong electrochemical forces between the soil particles. So these are the differences between coarse grained soils and fine grained soils, or CGS and FGS. Going forward, this is flowchart of particle size distribution. How to distribute the particle sizes? Actually, particle size distribution is a method of separation of soils into different fractions based on the particle size. It is also known as mechanical analysis. It expresses the proportions by mass of various sizes of particles present in a soil. The mechanical analysis or particle size distribution is performed in two stages: dry analysis and wet analysis. Dry analysis is also known as sieve analysis. Sieve analysis is meant for CGS, coarse grained soil, or we can say particle size greater than 75 micron. Moreover, CGS is divided in two types: coarse size sieve analysis and fine size sieve analysis, where coarse size sieve analysis consists of a set of coarse sieves starting from 100 mm to 4.75 mm and particle size 4.75 mm to 80 mm are often known as gravels, where fine size sieve analysis consists of a set of fine sieves starting from 2 mm to 75 micron, and it will give particle size from 0.075 mm to 4.75 mm, often known as sand. Coming to wet analysis or sedimentation analysis, it is meant for FGS, fine grain soil, or we can say particle size less than 75 micron. For wet analysis, generally this method is used. It is called hydrometer method or pipette method. Moving forward, sieve analysis. It is performed to determine the particle size distribution. Sieve analysis is done as per IAS 2720 Part 4 1985. Apparatus required for that is a series of sieve sets ranging from 4.75 mm to 100 mm and 4.75 mm to 75 mm. I mean coarse sieves as well as fine sieves. Then balance, which is sensitive up to 0.01 gram plus or minus. Let us understand procedure. Take 1000 gram of soil sample from disturbed representative sample. Conduct sieve analysis using a set of standard sieves as per given in the data sheet. Data sheet is shown here. The sieving may be done either by hand or mechanical sieve shaker for 10 minutes. Weigh the material retained on each sieve. This works like as per shown in figure. Coarse soil particles are retained on larger meshes and finer soil particles are retained on finer meshes. Therefore, after 10 minutes, all type of or all sizes of soil particles will be settled. Then weigh the material retained on each sieve. Then the percentage retained on each sieve is calculated on the basis of the total weight of the soil sample taken, which was 1000 gram earlier. From these results, the percentage passing through each of the sieves is calculated. Draw the grain size curve for the soil in semi-logarithmic graph provided. We will see this graph later. First of all, let us see how to write observations. Sample details, weight of sample taken for sieve analysis. Here we have taken 1000 gram, or we will take 500 grams, or accordingly we will write the weight here. Then location. Now this is the observation table or the data sheet. Here serial numbers are there. IS sieves starting from 20 mm to 75 micron is there. Now after shaking of sieve of 10 minutes, we will fill this data after weighing them. Here we will write mass retained in grams, here mass retained in percentages, cumulative retained mass and cumulative passing percentage. This will give us some data, and that data will be helpful to fill a semi-logarithmic graph which shows particle size distribution. Let us go further and see that graph. This is particle size distribution curve graph. A particle size distribution curve should be plotted with percentage passing on natural scale or ordinate scale and the particle size on abscissa or log scale. It is also known as grading curve. This is a sample curve which is showing different grades of soil particles. In this graph, in this curve, 3 points are very much important. These are D10, D30, D60. Now, what is D10, what is D30, and what is D60? D10 is showing particle size such that 10% of the soil is finer than this. D30 is likewise particle size such that 30% of the soil is finer than this. And D60 is likewise again particle size such that 60% of the soil is finer than this. Now, question is, why should we use grading curve where it can be used? So, let us see uses of grading curve. So, grading curve is used in the classification of soil, or we can say classification of CGS soil. Particle size distribution curve is also useful in soil stabilization and for design of filters, drainage filters, and design of pavements. By using grading curve, we can also know that the susceptibility of a soil to the frost action or freezing action. By using grading curve, we can also know that what will be the coefficient of permeability of the soil is. So these are the uses of grading curve or particle size distribution curve. Moving forward, D60, D30 and D10 define two quantities which are known as coefficient of uniformity and coefficient of curvature. Formula for coefficient of uniformity is Cu is equal to D60 by D10. If Cu is less than 5, the type of soil will be uniformly graded soil. If Cu is in between 5 to 15, the type of soil will be medium graded soil. And if Cu value is greater than 15, the soil will be well graded soil. So we also can say that the larger the numerical value of Cu, the more is range of particles. Let us understand coefficient of curvature. It is nothing but a factor representing the shape of particle size curve, and formula of Cc is equal to D30 square by D10 into D60. Now value of Cc, if it is nearly about 1, the soil will be uniformly graded soil, and if Cc is ranging from 1 to 3, then the soil is well graded soil. So these were the indicators of type of distribution of particles of different sizes in a soil mass. I conclude this video here. Thank you.